Hello everyone and welcome back to part 19 of Python full course, and today we're going to be looking at map, filter, reduce as well as lambda functions to get a look at functional programming in Python. So let's get started. As always, let's just open our new file, create a directory, and add our file main.py. Now we're going to look at lambda functions first. And lambda functions are a neat, concise way to write functions in one line, but you only need to use them when you want to use it only once. So what do I mean? Let's say that I had a function that took as input another function, and this function is called map. Map is a function from Functools, which is already imported, that you take a function and then you pass something that is iterable or a list, and then it will return something that you can iterate over. So I can say map lambda x, then colon x plus 1, and then I say, for example, the list 1, 2, 3. So I have result is equal to this, and I can print result. Now, if I just open a terminal and I go to the right folder, then I can just activate my conda environment so that I can run stuff. And now all I need to do is just to run the file, so python main.py, and I have a map object at 0x, whatever that means. So if you really want to see it, all you need to do is that you want to convert it to a list before printing it. And now you see we have 2, 3, 4. So the syntax of a lambda function is that you do lambda and then you say parameters, so for example x comma y, and then you put the colon and you have to say something that you return. So you don't need to put a return keyword, you just need to say that you return. So x plus y, and this is going to automatically return x plus y. If you don't want to put any parameters in your lambda function, then all you need to do is just put lambda like this, colon, and then for example you can say 1. And it's just a function that takes nothing and it will return 1. So let's just do more examples with the map. So lambda x, let's just change it to lambda x, then x times 2. And now if you run it, we see that we'll have nothing, and then just say print list result. Now we have 2 for 6, so it's multiplied by 2. Sometimes if your function gets particularly lengthy, then you can use a lambda function and then transform it into a real function. Well, not real, but like a function using the def keyword. So define, applied, define my function. You would take as input x, and then let's say I take some very complicated operations such as x times 2 plus 1 minus 25 plus 64 times 3 divided by 5 minus 10 plus 20, and I return this. Of course it could fit into a lambda, but just assume that it was a function that's so big that you cannot fit it in one line. Then now your map statements become quite elegant. It's just map my function, and now that's it. So you run it and then you see that you have the thing that you want. So let's just make a contrast with list comprehensions. And for list comprehensions, you have to say square brackets, then you have to say my function x for x in 1, 2, 3. So result is equal to this. So which one do you think you prefer most? I personally don't really have any preference, but I do think that map sometimes come in really handy when all I want to do is that I'm not going to use a lambda, but more a just function that's already defined. Because when you use list comprehensions, there's no need for lambdas. All you need to do is just say x times 3 plus 5, the expression directly, and so I think it's just much more readable in this case. So I only use map when I have, for example, functions that are named using the def keyword. Another thing from the Functools package is called filter, and you can guess it correctly, it filters stuff. So from Functools, import filter. So let's say I wanted to filter everything that's smaller than 2. So filter lambda x, and now I have to return a boolean value that says whether it's smaller than 2. So x smaller than 2, and we'll see if this is really what we want. So I know for a fact that's not going to be what we want. We want to keep everything, we want to filter out everything that's smaller than 2. This is not going to do it, but we'll just see what it's going to say. So let's do it again. And now, so cannot import this, so if I remember correctly, it's just going to be 1. So you don't import it from Functools. I do remember, however, that before it was in Functools. So now you don't need to import Functools, you just need to say filter, and then filter, what do you put as function? Lambda x, x smaller than 2, 1, 2, 3, and what did it return? It only returned 1. So the logical explanation is that this thing that you return here, the boolean value, is that when it's true, it's going to keep it, not when it's false. So x smaller than 2, so which one of them is smaller than 2? It's 1, and since the only one that was smaller than 2 is 1, then it's going to keep it. So if we want to reverse it, then all we need to do is that we just need to say x bigger equal than 2. And now we have everything we want, 2, 3. Finally, we have reduce. So from Functools, import reduce. And now I'm convinced that this is actually from Functools. And now this is very useful, for example, when you have a list and you want to perform some sort of accumulation on it. So what the hell do I mean? Let's say I had a list called my list is equal to 1, 3, 4, 5, 6, 2, 3. And now I wanted to be able to, let's say, take the sum of it. Then all I need to do is just say reduce. Now I have to put a function, so lambda, and now it takes 2 parameters, so an accumulated and element. And now I return what's going to be returned, so accumulated plus element. I'm just going to explain what's going to happen later on. Then my list. Now I have to put an initial value, so I'm just going to say 0. So reduced is equal to this, and print reduced. Let's go. And now we have that reduced is of 24. I'm just going to factor it into a multi-line function, so define my reduce func. It's going to take accumulated L, then print and return app plus L. Let's just confirm that everything is working, so my reduce func. And now, see, everything is working. So I just passed a function to reduce. It's going to take something that's accumulated and then do something with the element that's currently visiting and then return the new accumulated. Let's just print what's happening. So print f accumulated equal to accumulated, L equal to L. That's nice. We have that at first the accumulated is 0 and then the element that we're looking at is 1. So here, this is 0, the initial value, and then it's 1. Now, we see that we have accumulated equal 1 because 0 plus 1 gives 1, so this becomes our new accumulated, and we have the current element we're visiting is 3. Now, we see that what we need to do is just return acc plus L, so 1 plus 3, and this becomes the new accumulated, as you can see, 4. Now, 4 sees 4 from here, sum them together by the function, you get 8. And now you see 5, 8 plus 5, 13. Now you see 6, 13 plus 6, 19. Now you see 2, then plus 2, 21. And then now you see 3, then 21 plus 3 gives 24. So this is very, very awesome. Another cool thing you can do with the reduce is that as long as you think your function cleverly, then you can do lots of stuff. So anything that involves taking a list and then giving one value for it can sometimes be expressed quite elegantly using a reduce. Let's say I wanted to get the maximum of the maximum element in the list. Then all I need to do is just change this function and then say if accumulated bigger than L, then I return accumulated, else I return L. And for the initial value, I'm just going to say that the initial value is just going to be minus infinity. So it's been a long time since I've seen that, but I do believe it's float and then minus inf. So I'm just going to test that because I don't want to do that stuff. And as you can see, yep, this is correct. So minus infinity. And minus infinity is just defined so that it is smaller than everything. So minus this, minus this, minus this, minus this. So it's just smaller than everything. That's just how it's defined. So this is going to return minus infinity if there's no maximum. So if accumulated bigger than L, return at, else return L. Let's just print reduce now. Now we run it, and as we can see, we get 6, which was the maximum. So this, I think, is just very elegant compared to having to do a for loop and saying for L, for element in my, so I'm just going to define max, my list, and then I would have to say for element in my list, if element bigger than global best, then global best equal to element, and then I have to say global best is equal to float minus infinity, and finally you have to return global best. Now if I just say print get max my list, I run it, you see I get the same output for both of them. But honestly, tell me, which one do you prefer? Get max using all these lines of code that are quite repetitive, for loops and all of this, instead of this beautiful reduce function that just says when it's bigger, return accumulated, else return L. Now I'm going to show you something that's going to make it even prettier. We don't even need a reduce function. So reduce lambda accumulated element, and now I'm just going to return max of accumulated then element. Let's just run it, and now we see that we also have the same result. So I'm just going to only print it 6, it works correctly. But wait a minute, all we're doing in this is that we're having a function that takes accumulated element and then pass these in the exact same order to the max function. Then we just need to do max reduce max, and now voila, we have an even more beautiful function using functional programming and no for loops. So you reduce max my list float minus infinity. And if you want to get the minimum, then it's so easy. All you need to do is just take min, and here you just do positive infinity, and now we have the smallest element. It's just so much more elegant using reduce. So that was all about Lambda functions as well as Functools. I hope you like it. Thank you for watching. If you like this content, like, subscribe, do all that good stuff. And in the next video, we're going to look at generators, iterators, as well as the yield keyword. So stay tuned.